In this video, we will see the cost function for the neural network. Just to compare with the previous cost function, logistic regression, as you remember, the cost function for logistic regression was represented using j of theta, and the formula for that was -1 upon m. Sigma is equal to 1 to m y of I log h theta x of I plus 1 minus y of I log 1 minus h theta x of I plus lambda upon 2m. Sum of j is equal to 1 to n theta j square. Reminding about the function, this lambda upon 2m is the regularization term and lambda is the regularization parameter. And in the neural network, we are using the same function. We are going to use the same function by simply making some minor corrections, as we will be having multiple layers, multiple hidden layers in this neural network. We will be using an additional summation component for each layer. So the neural network is different altogether, and the formula for neural network's cost function is j of theta. As you can see that this theta is the capital theta. Earlier we were using the small theta, which was representing a theta vector. Here we will be using capital theta, the kind of matrix, and the formula is j of theta is equal to -1 upon m, the same as it was earlier there, and the into the bracket called sigma I is equal to 1 to m and sigma k is equal to 1 to capital K. Now this is something which we have added, and this has been added to make sure that we calculate the cost function considering all the hidden layers in the neural network. Apart from that, if you see here, you have y of I, here it is yk of I. You have log h theta x of I, here also it's log h theta x of I k plus 1 minus y, here you have 1 minus y k of I log and 1 minus h theta xi. Here you have the additional k subscript, which represent that you are adding a nested summation for each layer. And finally, for the regularization term, instead of single summation, here you have three summations. L is equal to 1 to L minus 1, I is equal to 1 to S of I, and J is equal to 1 to S of J plus 1 theta J I L square. Here you have the three summations, and you see that L is equal to total number of layers in the network. We are not calculating the all layers because we will not be considering all the layers as the calculation layers, excluding the first layer, so it's L minus 1, and SL is the number of units. Here we are not counting the bias unit in layer 1. Putting all together, this is the new formula where you have the cost function for neural network, and the formula is quite straightforward and quite easy. If you remember the logistic regression formula, this is the same as what we have in the neural network.